It's hard to believe, but people didn't used to believe in negative numbers. People thought negative numbers were stupid. How could you have a negative amount of wheat or a negative acreage to farm? If it didn't mean anything in that physical sense, then it was of no use. Well, algebraically, pretty quickly, negative numbers do have a meaning, and so it's a natural thing to make the number system that you use allow negative numbers. There are objections that are raised all along the line, no matter what extension you consider. If you don't want to allow negative numbers, maybe you don't want to allow fractions. Numbers exist that are real numbers that can't be written as fractions, and sometimes it takes a while for people to realize that you have to decide up front whether or not you're going to allow those kinds of numbers in a number system. When we do algebra, usually the focus is on the set of real numbers, and for real numbers you've got this nice link between numbers and points on a line. That's why they call it the real number line. Algebraically, you get into a dead end sometimes if you restrict yourself to real numbers. The standard example is an equation like x squared equals minus 1. X squared equals minus 1 has no solution in the set of real numbers, because no matter what you try to use for x, negative or 0 or positive values for x, when you square a negative number, the answer is positive. When you square 0, it stays 0. When you square a positive number, it's positive. There's no real number squared that could be minus 1. So you say there's no solution, or you take the approach of crafting your number system so that solutions are allowed. To do that, you have to invent a new kind of number, a number whose square is minus 1. And that is what starts the set of complex numbers. And you can do arithmetic in the set of complex numbers just like you do in the set of real numbers. Now, you feel like complex numbers, well, you can talk about imaginary numbers, and that's kind of a put down, because if they're imaginary, it's sort of like your imaginary playmate. It's not real, it doesn't exist in some sense. But it turns out that complex numbers make lots of sense in physical situations. There are times when you need complex numbers to model physical phenomena. That happens in electrical engineering in particular, that you couldn't do otherwise. So this is about complex numbers, and the tools that we've been building about trigonometry will help do arithmetic with complex numbers. Let me show you how.